Hello, my name is Francis Blay. I'm a part of section 1004 of EMA 351. During my Lab 8 section, my laptop died, and so I was not able to get a complete grade for my work. Here's my email to Stephen Mitchell, and here is his email saying that I should plan my lab during makeup and that the 30% deduction will be waived. This is my voltage follower, this is my inverting amplifier, and this is my integrating amplifier. So for my analysis of a non-inverting op-amp, I took the KCL of the two resistors. So when I did this, I got the equation, the output voltage minus the input voltage over R2 is equal to the input voltage over R1. And when I solved for the output voltage, I got the input voltage plus the input voltage times R2 over R1. And there we can solve for the gain, which gives us 1 plus R2 over R1. Hello, my name is Francis Blay, and this is my makeup lab for Lab 8. So for the first part, we have the comparator. So as you can see, if I switch the potentiometer all the way down, it turns off the LED. But if I turn it up to, I believe, one measure was about 2.4 volts, the LED does turn on. So for my voltage follower, we can see that right now all the input voltages V minus, V out, and V plus are around the same value. However, once the input voltage falls below around 1.7, V out and V minus will stay around 1.7 while the rest are allowed to decrease to 0. So for the inverting amplifier, we can see that once I increase the input voltage, the output voltage also decreases, and the output voltage will decrease until it reaches around 2 volts, which is where it plateaus. And then once I put the input voltage below the 2 volts, then it starts to increase to around 4 volts. So we know that the current going through the resistor and the capacitor is equal to each other, and we know that V plus is grounded, so that also means V minus is grounded. So when we take all this into consideration, we can get the equation V in over R is equal to the capacitance times the output voltage derivative as a function of time. And so once we move terms across the equal sign and integrate, we get the final equation of Vn times time over Rc plus the integration constant is equal to the output voltage. So for my integrating amplifier, I get this response. Once I turn it up, V minus is following Vn. So when I turn Vn and Vn all the way down, it stays around 4.5 volts. However, once I turn it all the way up, V out then goes all the way to goes down to 2.5, well, around 2 volts.